Welcome back. In this video I'll be solving Leetcode problem 707, design linked list. Designer implementation of the linked list. You can choose to use a singly or doubly linked list. A node in a singly linked list should have two attributes, value and the next value is the value, next name, previous. Well, for this one I'll use double linked list. So class node will have init self dot value value self previous is equal to none, self dot next is equal to none. Okay, implement the class. Okay, so I will need to have a head and tail. So self dot head is equal none, self dot tail is equal none. If get so I need to find some index. Well, nothing too terrific. While index is not equal 0, if is equal to self dot head, if current, if not current or not current dot next, and just return -1, because if I was at index 0 then I would return it, and if I was, I would return just that value, and that's it. Is equal 1, so this should be, and if it's 0, this is just in case if it's 0. So, and there is nothing. Okay, add at head for the first node. Also, the new node will be the first node of the linked list. Okay, so if I add at head, this will be okay. So node is equal to node with value. Okay. So node dot next is node dot head. That's for sure. Is self dot head. That's for sure. Previous can stay the way it is. Self dot head is equal to node, so that part is solved. If self dot tail, if not self dot tail, I will also self dot tail is equal self dot head. And that's it. return nothing. Okay, added tail. So it's almost same logic. So node next. So this is node previous. So dot tail. So tail is node. If not, so this add at index. So before the index, add a node firewall before the index. Okay, so well, I will have to get the index. This gets the value, so if self dot get index I need to read this again. So but then I need index. I need this. I'm doing add. So if this exists, this should be I could try what else with it. So if self get index -1, because I want to see that the last one exists. If it's not equal -1, then exists. And then I have to find it. If it's equal -1, then I'll just return. And if it's not, I have to go to it and just add. So I'm essentially doing again this part, but a bit differently. So current is out of head, all index is equal to 0. So this is the, let's see, the first one. I will have to find, this is how I'm going to find the previous node. This is, current should be, I think, previous node now. And it should exist, so I don't care about this part. So helper is equal to current dot next. Node is equal node with the value. non.previous is equal to current. Now.next I don't even need a helper. That's it, and just return ith node. So again, just return, and if not, I again use this. Current is self-add, all index is not 0, if not current or not current. This will never happen. So I will go to the index that I need to, and I just have to go current dot previous dot next is equal to current previous next is current next. Current next previous is equal to current previous. That seems it. Non-type only has no attribute next. So added head, that's 1, 1, 1, added till 3, so 1, 3. Added index. Okay, my bad, yeah. Well, this means that I was told to delete and on top. So, oh, yeah, I didn't copy everything, so even add. Okay, this was silly. So if not current or not current next, return current next. Stupid. Okay, and it's possible that I'm deleting at the beginning. So if it's 0, okay, I really did it pretty bad. So let's be careful this time. So yeah, when I added the index, if I had well, maybe I messed up a bit by using double linked list, but let's try to get it through. So at both of these I have to be careful regarding tail and head. So let me think about it. So if if head was none, not self, not head, else current. If not, well, if I don't have a head, then it's none, or 0, then I have none. Now the next is equal to what have I done here? So node this is completely bad. It seems I'm getting tired, so I find the index. Let's imagine this is when index is not 0. Let's say it this way. Index is not 0. Index is something. So I got to, and I went to the previous node. So the next one is, okay, so node previous is current. Node next is current next. Current next. Previous is node. Current next is equal to node. This is if it's middle. If current is not equal self.head. Oh, this is complicated. This is crazy complicated. But let's push through with this. And delete at index, this should be easier. So current previous next. So if a current of its previous next is current next, and of current next previous is current previous. Okay, but for this situation, I have three cases. So this is middle node. If, let's see head. So index is equal 0. Index is equal 0. That's the only way I can write it head. So self dot so if index 0, and it will be 0 all the time. And I'll look for index -1 and index -1. Yeah, it will be infinite loop. So let's do this here. So if index is equal 0, then I build a node. Well, then I can just call, let me do this, self dot add added head, and I push value. And I return an added head. We'll take care of that. Okay, so that part is finished. If self get, okay, so, and now I have either it's a middle node or last node. What's the difference if it's last node? So if it's last node, current dot next is none. So this part, if cur next exists, then current of next previous. Next node is nodes. Okay, I think I fixed this and deleted index. This could potentially work. So non-type deleted index. Let me now check. So if I delete that index, index 0, so if index is equal 0, then I just have to update the and if next, so if this exists, let's use this. So if it's 0 and it doesn't exist, then I just return. So if it's 0 and it exists, then I have to, if I delete that one, well, at least I know that head exists. So current, so if current is not equal self dot head, then current previous next is current next. If current else, if I have to delete head, then I have to check if it's not previous current dot next, whatever it is, because current exists, else if it's not equal head. Now if it's equal head, then I have to update my head. Then I have to self.head is equal to current.next, and if self.tail is equal to current, then self.tail is equal to self.head. Okay, that's this part. So if it was head, and if it's tail, if I'm deleting the last element, if current is equal to self.tail, or if it's not equal tail, then I can do this. But if it is tail, I have to do the same thing. Well, let's do this. If self.head is equal to self.tail is equal to current, then self.head is equal to it's none. Tail is equal to none, and now I just return. And now I do this part. So if current is equal to if it's head, self.head, and head is not equal tail, then I have the next one. If current is self.head, okay, then self.head equal to self.head.next, and self.head.previous is equal to none, and I just return. If current is equal to self.tail, then tail dot previous dot next is equal none, and self dot tail is equal to self dot tail dot previous, and then I return. And if it's in the middle, then I have a node, so that node I'm deleting, So I need to go current dot previous dot next is equal to current dot next, and current dot next dot previous is equal to current dot previous, and return. Seems to me that this should work, but again, so current dot next, and then it should have been a tail. So current next previous, and this is none. Which part is actually next previous is current previous? What? Well, if current, either current doesn't exist or current next doesn't exist. If current next doesn't exist, then current is tail. If current doesn't exist, that's interesting. Current is head. And what if it's, well, this is tail. Well, then tail is not updated properly. So that goes to, yeah, and that's, so this is added head, and that's okay. Well, if it's last node, I didn't update tail for whatever reason. So if current next, current, yeah, that's a problem. So I didn't update the tail. So if not cur dot next, that means it's a tail. Then I do add at tail, add at tail. So self dot add tail, and it's a value. And I return. So this is only for a middle node. Add tail. Okay. Well, at least it's not an error this time. So I have linked list, added head 1, added tail 3. So it's 1, 3. Add at index 1, I add 2. Okay, so it should be 1, 2, 3. at that particular moment. So 1, 2, 3. Will it do that way? So edit index. If index is equal to 0, then self edit head. If so, index minus 1. Just return. So I was doing added index. I was doing added index. So added index 1, I add 2. And for that it was 0. So head. Okay, if it's a middle node, previous is current, node next is current, next. And what about current previous? So current, current previous, okay. Next has to be node. So get, this should be 1, 2, 3, and I should get at 1. Current is self.head. While index is not 0 if not current or not current. Next. Not current or not current. Next. And index was, oh my god. Yeah. Well, again, it's bad. This code is a bit of mess. So if index current or not current. Next. Current is current. Next. And index was now 0. And current was current. Next. Okay. There is no reason for turn current value. It's not weird that acceptance rate is this low. Let's just try one more lucky run. So my get is not working properly. Print list with no input. I'll use self. And I will just while so current is equal head, so not head, if not current, print it's empty, else I wanna while not while current print maybe have out current out and value print out current is equal current of next, and let's now print for the get, let's what's the name, print list. Let's see. It was always just one. So I added at head. Interesting. Do I do this correctly? So if current is head, current is current next. Okay, seems that head. So when I added at head, it was correct. It was 1. Then I added at tail. So tail was nothing, tail and head were same. So node value, node previous was self tail, which should be head. And self tail was now node, and self head was already something. Print self dot head dot value, print self dot tail dot value. No, I want to do add and also I'll debug this if it requires till the end of my days. And tail, and let's see what's wrong with this print. Let's see, add head. So when I added a head, it was 1. When I added tail, it was 1. What the heck is this? So when I went add head, it was good. Okay, am I crazy? So tail, they were the same. Not previous. Tail dot next is not. Okay, crazy. Yeah, I think this is what I missed. Maybe, yeah. Let's hope. Okay. Well, at least I can now debug. Current previous next is current next. That's the current previous next is current. Crazy. But let's see. So delete is not properly done now. It again seems that something is off. Okay, so first I had a list, then I added at head, that was 7, then I added at head 2, that was 2, 7, that's correct, then I added at head 1, that was 1, 2, 7, that's correct, then I got add at index. Okay, seems that this is not good. Add index, and I want to just let's see this one. I think I'm close, but we'll see. So I went to add index, and I was adding at index, so at index 3 I was adding 0. And what does the added index do? So add before the eth node. So this was doing, so this was doing 0, 1, 2. It was adding at position 2 essentially. Well, that was correct. So this was also good. So it was 1, 2, 7, 0. Okay, it was 1 to 7. Then I went to get, and it was 1 to 7. And then I, since it seemed to be at tail, that's why I added at tail, and I got 1270, and then I got delete at index 2. So I got to delete to index 2. And head should be okay. This looks also good. So we went here, we said self get index if it's -1. Well, at 2 it was not -1, it should have been 0, 1, 2, so I should delete this 7. Currently self.head is not equal 0. Current next, so current was here, current was now here, and it was index was 1. This was 0, so I was here. So if self-head is equal to self-tail, that's not true. What is the error? Current non-type has not next. Okay, this only seems that the previous connection was not done properly. Let's just this is an issue. I should get the same thing, but I won't get the same thing. You see. I have, okay, so we found an issue. So when I was 1, 2, 7, I had 1, 2, and 7. Okay, and when I added head, so it was first at have and 7. Let's just print this from head, so it's a bit clearer. So from head, from tail, from head 2 and 7, and from tail it's only 7. Okay, so it's clear where it was messed up. So when I add at head, so node, okay, node next. Well, isn't this the same thing I messed up over there? Yeah, it seems it is. So node is, this is new node, node next. Well, so am I crazy? It's like I'm really crazy. So self dot head previous is equal to nodes. So non-type object. Okay. So self dot next, self dot head is equal to node, and now I need to check if self dot head dot next exists, and self dot head dot next node previous is equal node. So this was the issue. Now let's try again. Okay. another error. Wrong add tail and get 0. Okay, this is the same thing, so we don't know that the self dot tail I'm not sure that tail exists, so I will need to do the same thing. So if tail exists, so if self dot tail node previous is self dot tail. If node dot previous exists, then node dot previous dot next is equal to node. Something like this. Okay, and I think we got it. We just need to remove all these prints. Let's hope We got it. Quite crazy. And got it working. I have nothing to say about this one. This one was a bit over the top, but it's working, so hooray. Time complexity, space complexity. Well, at least I got to exercise double linked list. Whew, time complexity. Well, for all of this, it depends of what, but deleted index we have to output of n. So let's go one by one. Added head of 1, added tail of 1, added index of n, because I need to find the index. Deleted index is the same thing, so let's put it off n. End of 1 should be, because yeah, we don't have any extra data structures for anything, so we just take a note. Okay, 116 lines of code with some spaces, so nice. I'll just stop from the start. So this, added head, added tail, added index. Let's just return under. Delete. So it's visible, and deleted index. And that's it. Yeah, this was long one. I think it's the longest possibly I ever did. So yeah, I won't take more of your time. I appreciate you following this one, and see you in the next one.